Hey guys, welcome to DevOps School. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you.
But before that, let me ask you a few things. Are you dreaming of a career with higher pay and more responsibilities? Or are you ready to take your skills to the next level this year? Then start investing in DevOps School certification level courses which will help you to emerge skills for a wide range of entry-level roles and as well as higher potential future positions. But with thousands of courses online and in classroom worldwide, finding the right one for your career goals can be difficult. You can consider our courses like Agile Developer, Agile QA, DevOps Certified Professionals, Site Reliability Engineering, DevSecOps, and Masters in DevOps Engineering, where you will have access to well-structured, easy-to-follow course content that has been developed and will be delivered by industry professionals. You can join on our training programs globally through online platforms, and if you are looking for classroom workshops, then we have regular sessions available in Bangalore, Hyderabad, Chennai, Delhi NCR, Mumbai and in Pune. Simply compare our many courses, find the one that suits your style and schedule best and start today.
So I'm going to talk about three topics now. Prove what is container and how to troubleshoot a Docker, and before that how to use containers, how to work with or use containers. That is it. Okay. So three topics. Next 45 minutes I believe. Okay. I will give you the demo and I'll explain it to you also. These are the very important topics there. Please carefully look at it. Just don't ignore it. Okay. So first thing, I said container is nothing but user space. If you look at it here I said, right? So, here, technically, so it's a user. It's a user with PID, memory, and network. So let's not try to prove what is container. Let's try to find out yourself. Who are you? Who are you? See, I am Bash right now. Correct now? I am a Bash. And Bash has come with a sudo. So can we trace this PID? Yes, this is a temporary process. This you won't find it. But right now I am a Bash. You see, if I run one more time, look at it very carefully, please. See? This two is not changed. This switch keeps on changing one more time. See here. That means I am Bash. And Bash and sudo with the root. So can I trace it myself? Who are you? I'm tracing my origin actually. So let's trace it. Here. ESFNEF grep. And see. Which is your origin? See here. 182.1.4 which is a sudo. So basically I am this right now, but this has come from this one. Parent is this one, parent ID, PID we call it, right? So for this is the parent. Now I want to trace 214. 214 has come from this one, which is sudo -s. This is 214 is sudo -s. And this has come from this one. Let's trace it back. Keep tracing the parent. See here. 18195. What is that? It's the Bash. But if you see that here user is root, here it was employer. So I was here, then become here, then become here. See that current traverse between this process. Here, I am here right now. Now this is having parent this one. Can I check this? This parent is this one, whereas this one is SSD service. This is SSD. Remember, I am connecting to the putty SSD, so this is all. Can I travel us back to 91? I'm facing myself. When I see that, here you see privileges, capabilities. Remember capabilities versus the capabilities. Here. This is where you see this is run by root. Capabilities, remember, this is the capabilities. If you remember, this one I said, how can you decide which user will get what kind of privileges? And here I said capabilities. Here is that. And it's done by root because only root can access it. So now can I transfer this to 1230? See, 1230 is basically SSD and SSD, which is a service is the being mode. And if you look at the parent 1, for this is 1. See, want to see 1? Let's take it out. See, this is 1. What is this? 1 here, system D. And 1 has come from where? So, you saw that yourself, you traced yourself, you found out you all come from the 0. How come you got a PID table? Because it had 1 more. So now guys, you are user. Okay, you are user. You are also kind of process itself for the system. So similar way, if you are a process, containers are also process. Don't you think so? Right? Because container is also user, right? Don't you think so? Right? Are you able to understand me what I'm trying to say? Yes. So can I now trace the process of container? So Docker PS, see I am having 3 containers running. I want to stop these 2 containers for quick clean them, okay? I'm stopping. Only 1 container is running right now. Docker PS. See here. Only 1 container. Can I trace this one? Look at my screen, please. See, this is the Docker D, but this is the container one. Look at it very carefully. This is the container and container run by root. Okay. This is the command which is running the container. So container runtime environment runs C. This is it. Runs C. With the help of the container team. Okay. So this is a runtime environment. Okay. So now if you look at this here, this is the container process 19015 and trace it, that guy also. Trace it. See here. 8979. Let me trace it back. See, 8979. This is the container D. Because if you remember the architecture, again look at this, my architecture. Here I said, see, container D. So container D. So basically this container is managed by container D. Okay. And container D, if you look at it, CPID 1 again. And I showed you what is 1 system D. PID 1 system D, which is running as a daemon mode. So guys, you are containers, you are process, And in fact, containers are processed also in the host machine. So guys, did you understand this, what I'm trying to say? Guys,
Rajesh, how did we trace it back to containerization?
just keep grabbing, you will get it.
So which here is the parent ID?
Parent, see here, this is the container ID 19015. This is managed by 8979, which is a container D actually. Parent.
Okay.
So you trace yourself in this method, you will get to know who are you, who is your parent, from where you got origin actually. So you'll get to know. It's all about the PID mapping which I showed you in the morning session. Okay. So guys, process. Now you must be wondering, okay, right now who are you? Root. Do you want to log in? See, exit. Look at my screen guys, please understand. Exit. CentOS. Sudo -s. Root. Exit. CentOS. Lesser privileges. More privileges. So how easily you can get it? Because you are a 2 user right now. You are a 2 user. But that user is not managed by system. Understand that. Containers user isolation is not managed by operating system directly. They are being used indirectly. So how can you do that? How can you switch to the gen? How can you switch to this user? You have to do something like a docker attach, and I'll teach you. I'm just showing you here. Docker exec also you can do that. Exec separate. I'll show you all this command. Just don't read the command. Understand the concept actually. That's important. Okay? Command I'll teach you. That's not a big deal. See here. See? I am logged in as a container now. Jenkins. It's a container guys. See here. Container. See ps-es. I told you in the container it's a complete isolation. So see here. It's isolated. Why you are not seeing the system process? You want to come out of it? See here. ps-es. See, this is my system process, but I'm not seeing the system process. See, I'm not seeing the system process. Why? I am not seeing the system process. Why? Because I told you very clearly, each container will get one PID. See here, 0, 1, 6, 90, and so on. PID means starting with 0, 1, and something like that. So this container also gave their own PID internally. See, again think about it logically. If you are inside a container, you got the independent PID. But if you are outside of the container, that container is a part of the host machine PID. Think logically. So how this mapping? So I've shown you that image actually. This one. I think did I close it? Yeah. See, this is the image. From you are 8. Understand that simple. For the system, you are still 8. From inside, if you look at this, you are 1, 2, 3, 4, 5. Why? Because it's a one PID. Each user get attached to one PID net, a PID namespaces. So guys, are you able to understand this? PID and user. Did you understand this? Hello.
Yes, Rajesh.
One more thing here I said. Each container will be mounted with one mount. Again, if you recall the discussion, go back a little bit. I said very clearly, copy of image get mounted at each container. Each container. So if I show you here, come out of this container, df-kh, see here, see someone mount. This is a copy of image got mounted to this container. Want to see one more mount? Let me start one more container H. Docker start exit container. Guys, look at this here. Docker df-kh. See, two mount. One mount, two mount. Now, you want to see the content of this? CD. Have you seen this somewhere? Look at this where I am. Have you seen somewhere this one? What is this called? What is this called?
File system.
Root file system. Root file system. Now you want to see something similar in the container? Let me show you here. Docker. I'm not teaching you command, I'm just showing you the behavior, okay? So don't try to recall the command. Execute in this container df-kh, and you see here ls. See, this is inside a container. Any command which is running with the Docker, you are running inside the container. Okay. See another container SQL sheet. See here, same view. Why the same view? Because both containers have come from the same image. That's the reason same view. See that? See, both the containers come from the same image. That's the reason everything is same. But the behavior will be different. Can I prove it? See that? Mapping is different. Let's do this. Let's out this file. See here. This is the file. You have same file which is similar to B1. See, same file. But anything which is after that you will maintain separate. How come? Let me show you. Touch. Think. Rajesh.txt. See, I created in a B1 Rajesh.txt. Can I show? 87. This is 87. Do you have Rajesh.txt? No. Can I see the B1? Do you have Rajesh.txt? Yes. See that isolated copy, complete independent. So guys, what I'm trying to say, each container will get their own mouse. Now I said each container will get their own network host. How can it be possible? Let's check it out. There's two containers. Can I see the network? Inspect. Container ID. Grep. Because it will give you so much of information. I'm graphing. What is the IP address? See here. 2. Can I change the container ID? See, 3, 2, and 3. So guys, did you get an idea about this? Now you understood that isolation, how this containers is nothing but isolated part of your cell phone. Did you get an idea? Everyone?
Yes, Rajesh.
Okay, good. So guys, this command, I'm copying whatever in order to prove that I run it. Here it is. Guys, now it's important topic, very important topic. How to work or use the container. Because you have created a container, you have started the container, but how to work with and use the container, that is most important. So we should do that, right? I'll just put it in a simple way. You run the VMs, virtual machines. How to use that virtual machine? How to use that? So one thing you can do that, how can I go inside? Yeah. How can I go inside a container? The second thing you want to do that, how can I access from outside using port? These are the two things you do that. Either you go inside a VM or you come access from outside the VM. In this case, web will be the ideal way. Jenkins is a web-based tool, but to do over the command line, Jenkins you cannot use it over the command line. So how can I go inside a container? So guys, before talking about these two topics, I must tell you something very, very important, very important. And let me tell you, if you forget this concept, you will never be able to work with containers. It's so important. So guys, importance of the ID1. Okay, importance of the ID. The ID1. Remember, one PID get initialized, start with 1. Remember? 1. From 0, from nothing it come 1, and 1 to branch it out multiple. Here, look at the image, this one more. This is one PID table, okay? One PID. Parent names this PID. At the container level also there is a PID. But parent names. Conceptually, it's very simple. Let's understand this. Your physical machine is running, I'm just writing it here. Physical server is running only, please understand that, and if the ID1 is running. Okay, what happens? The ID1 is running. So, this is my virtual machine by the way. Okay, yes, I have running here. If I kill this PID1, you know what will happen? My system will shut down. Virtual machine will shut down. So, my physical machine will be running. In the physical machine also, if you look at the Linux, PID1 is running, so physical machine is running. Or virtual machine is running. So here, virtual server is also having same concept, guys. Virtual server is running. Very clearly I am saying, please take it seriously, this statement. Only and if PID1. If PID1 is not running, your system was shut down. VM is shut down. VM is stopped, exited, whatever it is, killed, whatever. So guys, are you comfortable? Are you getting what I am trying to say? All of you. Guys, Hello.
Yes, sir.
So now is the most important one. If container is running only and if PID1. Yes. If this is a rule which we have with the container also. That means if I tell you here Docker PS, these two containers are running. Why? Because PID1 is running inside this container. See here, PID1. What is a PID1? Bin tini, parameter 1, parameter 2. So that means this container is running only because of this one is running. If this is not running, container will get exited. Can I prove it? Let's go inside that container. I'll talk about it. Exec-it, container IT, then bash. Don't remember this command, I'll tell you one by one. Let me finish the conceptual part. See here. This is the PID1. Right now I'm inside the container. Can I kill the PID1? Kill. See? Did you see that? Where are you right now?
Root.
Root, yeah. Host machine. Wait, I'll show you this one more time. Docker. Second container is running. And here, see here. Then bash. This time again I'm inside the container. And this time I'll kill 6-1. Okay? I'm killing 6. Kill 6. Nothing happens. Now what has happened, you know? If I kill 6, think about it. If I kill 6, what has happened? I'll tell you first. If I kill 6, 6 is holding the Jenkins.bar file. And here Jenkins.bar file is being called in the Jenkins.sh. Jenkins.sh called Vintini. This is not running. This container got killed. So basically, PID1 got killed. That is the reason the container got killed. But we killed this time indirectly. We killed 6. 6 killed 1. And 1 got killed. Container got killed. Let me try to kill this time 95. Can you understand? Docker ps-a. Look at my screen very carefully. Docker. Start. Starting one more time. Docker ps. Now, if I go one more time, and this time ps-er. See, I have, this is a temporary process. This is me. This is me right now. This is a container is running with these two processes. So can I kill this 49 this time? You see, nothing will happen. 49. Okay? Nothing has happened. So ps-er, still container is running. Okay? Let's kill brutally -9. 49. See what happened. I brutally killed. Which one? 49. Do you think container got exited? Let's verify. See, still running. Why? Because this time, this 49 I brutally killed, but this was not having any relationship with this PID1. So PID1 did not got killed. And PID1 did not got killed. So container is running. So will you remember this one? Will you remember this? Right?
Yes, Rajesh, but one thing is, it is container theory only, not the parent system theory.
PID1 of container. PID1 of container. Like this. Okay guys. One more demo I'll tell you, so you will get confirmed. Let's use some other image. I got bored with you. Docker run Ubuntu. So here when you see Ubuntu, don't think it's a operating system. Ubuntu is the base image root file system. I have been always telling you here, always. Root file system is equal to base image. Okay, base image. Okay. So here Ubuntu, I don't want Jenkins, which is on top of the base image. I want Ubuntu, CentOS, Fedora, Debian, all this base image. You will get it. On top of that, we write a system. Now the question is, what is run? I don't know. So what we do in this case? We will learn. So let's understand that. Here, I am telling you, where is that? I had written, no? That's deleted or what? Got deleted. Importance of a PID1. Physical server, virtual machine, virtual server, content is running only and if PID1 is run. Okay. So very simple concept. So guys, this is that. So I'm playing with the Ubuntu image. Jenkins I'm not playing. But this time I've decided to run. So now I must be thinking, what is run? What is run? So before running this command, I will copy the history command, whatever I run, so that way it will be good for you. Okay. I just run this command. Now what is run? Guys, run is a special command. What exactly is doing? Let me tell you. So run will tell you, will do that few things. Which are the things? It will pull the image. It will create a container. Understand that? You will pull the image, create a container, start a container, and become or attached to the container. Now become a container or attached to it. How can you do that? Let me show you. Guys, tell me one thing. Who are you right now? Who are you right now? Who are you right now? Root, right? No, no. In this process table, who are you right now? Okay. You are bash. Correct now? Who are you? Yeah. You are bash. Now, I will change bash to become something else, become a container. You want to do that? Let's see. Docker run Jenkins. See here. Jenkins PID one was built in. Remember, I showed you already. Okay. So you want to become a Jenkins? Built in. See here. Pull, create, start, become. So, see, I was bash. Now I become a Benton. So what it has done? It created a container, started a container, and become that container. So right now, I cannot do anything because here I am a Bentini. And Bentini is not understanding any of your commands. Who cannot understand human commands? Only shell, bash shell, const shell, C shell. So Bentini is not understanding. You become that. That is what I am saying. Run has a special characteristic. You become that. This container is running and you become container. You become a Bentini. Want to see that? You have to open up a new console. Why? I'll tell you. CentOS. Spelling mistake. CentOS. Pro. Docker. Yes. See, this is me. This is me. Who are you on this? You are a Bentini. Now Bentini is a PID1, remember? And Bentini, how you can kill the Bentini? Control C. Exit command will not work because exit is a bash command, shell command. But this Bentini understand control C. See? PID1 I killed it. Continue. So guys, here I am saying run is equal to pull plus create plus start. Let me try with another image. Clear the script. Docker run Ubuntu. So Ubuntu will do this command pull create start become. Image is being pulled out. Can you see here? Where is that? Guys, where is that container? Can you see that? What is this got exit? This container of Ubuntu got exit. How come got exit? Any idea, guys? Guys, how come it got exit? Any idea? Hello? Yeah, it is not attached to the container. No. I think I told you, please remember this. I told you, very important. Container got exit because of PID is not running. Think about it. In the Jenkins, PID1 is running. So container is running. In the 1.2, PID1C, the exit is not a created. I told you created, difference between created and exit. Exit means what? Tell me.
It has run at least once.
Yes, it does run at least once. So guys, it has run, started, then exit and become an exit. So let me show you that behavior manually first. Forget about a container, Linux. See here, look at it back here. What is the PID one which got run? Then bash. See here, ls. I run ls. Okay? Echo $. Do you understand this command?
No.
See, then bash. Are you able to understand this command? What is happening?
Moving to root.
I am always root. When you run this command, it prints something. See here, ls print something, exit. Bin bash. You run some executable. This I am running here. Bin bash and exit. Think about it. So what is happening here is, look at this. Bintin is running as a process, service, never exit. You guys must be using this word, no? Hey boss, run as a service. This process is exiting every time. You must be telling all this thing in your work. Why don't you run as a service? Why don't you run this as a daemon? Okay? Why you are running manually? Every time is getting exited. So it's like that only. Here, bin bash is not a daemon. It's not a service. So it run, exit. Exit, container get exit. PID1 get exit, container get exit. Simple. Here what is happening? You run bintin with the parameter this. Never exit. Never exit. Container is running. Container is PID1 is running. PID1 is running. Container is running. Very simple calculation. Okay. So here, I was talking about the run. So it is a pull, create, start, become. Okay. So this is the one. Now how can we run the 1.2 also? I'll come back to this one by one. So guys, now if you don't want to become, so how to do that? -D says do not become. Do not become. So if I tell you, let me show you here, Docker run, it will create a new container. -D Jenkins. See, I did not lose my container. Console. Now container is still running. See? So -D means what you are happening. Pull, create, start, and detached. It's called detached. Detached. Okay. Do not become. So run with out D, you will become. Run with a D, you will not become. Guys, one more last thing I want to teach you, and that is, you know one thing, in the physical machine when you run, physical machine or virtual machine, whatever it is, in a physical machine, it is a system D. Yes, PID1 will be system D. Will be system D. System D, whenever you see D, you understand the daemon mode. Daemon mode means running automatically, it's not exiting. Because if you do not run in the daemon mode, you will get exit. Understand that. So daemon mode will be system D. Here virtual machine will be system D. Okay, understand that relationship. And guys, here in a container, anything, very important statement guys, is that means in the container PID one can be anything, and that is one of the reasons you must be seeing actually here. Sometimes if you see here, sometimes you have a container with a bintini, and sometimes with a bin bash, sometimes with Perl, sometimes Python, sometimes Java, sometimes this, sometimes that, sometimes anything. When I say anything, literally anything. So in short, this anything is running where container is running. So guys, this concept is clear for all of you? All of you? Guys? Yeah. Okay. So guys, let me teach you these two questions now. So first question is how to go inside a container. So guys, there are two methods which we have. The exec method which I have tried a lot. You might have seen it so many times. And second one is attach. What is exec? Guys, this is a very simple command. This exec command would execute. Okay, would execute an executable. Exec command would execute an executable inside a container. Understand that. So first let me prove this line. Okay, look at my screen guys. This is a container running Docker exec. Which container? This container ls run c df-kh. See that? Okay, see that here. Something what it says, it's running actually, but SSS is not found in the path. This executable is not found in the path. The reason it's not running. So if SSS is there in the path, it will in the path of the container, it will run definitely. So here it would execute an executable inside a container. Any executable and any executable. But guys, with, because you are a human being, right? You get with IT. IT means interactive. Okay? But with interactive and how human can interact with the system? How human can interact with the system? Any idea? With the command. Shell. Yes, guys. Without the shell, you cannot interact with the system. Shells such as bash shell, conf shell, c shell, okay, PowerShell. So here, when you are interacting with the any system, you will have to use any shell such as bin bash. Yes, so you can use this command to execute bin bash in an interactive mode to go inside a container. Yeah. See here. So can I do that? Let me show you here. Docker. See it here. Docker. Here. Docker. Execute. See here. Inside this container. Now I am writing the same command which I have already run it in the past. See. Docker execute this container. If I type simply bin bash You will not go inside a container. See, still you are at the host machine. But if I do with interactive mode, see where you are inside a container. Are you getting, guys? Are you getting, guys?
Yes. Yeah.
So, this is the behavior. You have to understand. It's all about the behavior, guys. It's all about the behavior. So, this is the commands which I try to understand exit. Now, you must be wondering, what is attach? So, guys, it get attached. Understand that. It get attached to PID1. Yes. PID1. Attach command will go to attach to the PID1. Right now, you have one container, Jenkins running with a Bintini, PID1. So you want to become, who are you right now? Bash. You want to become a Bintini? Let me attach to the Bintini to see the logs of Bintini. I did some mistake actually. This. What happened? Oh, sorry. Container ID. Not Bintini. You have to do the container ID. Where is that? Here it is. See where you are right now. Where are you? Where are you? Bintini. Yes. You are in Bintini, guys. And remember, Bintini understand control C, right? Don't understand any other command, but understand control C. I kill this PID1 and you see here, container got exited. Earlier we had two containers. Very simple concept, guys. Understand this. So here it gets attached to the PID1 and you know that very well. PID1 can be anything in the container. Now you must be wondering why this PID1 is changing. So guys, it's a developer call. Those who develop an image, they decide what should be the PID1. Depends upon the requirement of like whether you want to run something or you don't want to run something. So based on that, they decide. It can be anything. PID1 by developers can be set like a Java, Perl, Python, Ruby, Bash, Tini, XYZ, MNP, ABC, anything. Literally, I am saying anything. But that one condition applies. If that is running, then only your container is running. So how to make sure that is running? That is also developer's call. I will teach you how can you make this PID1, but for time being, understand that. Guys, how can you go inside a container? Exec way and attach. So guys, I will do the same demo right now with Ubuntu image. Okay, so see here what I am doing right now. I am creating one container. But what is happening with me when I say Docker? Okay, see here. When I say Docker, think here, Docker run and Ubuntu. If I say Docker run Ubuntu, it creates a container, but exiting it. I don't want to exit this. So can I do one thing? Can I interact with the container during runtime itself? So that way it will not allow to exit. Can I interact? Here I say IT. Yes, IT you can use with the run also and exec also, no problem. So when you do interact, of course you have to be some shell, right? If you are not any shell, you cannot use -t. So shell I don't have to use it, and the reason is Ubuntu by default run with a bin bash. You can write it here bin bash, but anyways Ubuntu PID1 is a bin bash. I don't have to write it, so I can skip it. Where are you right now? Where are you right now?
Root bash.
I'm inside a container, guys. I'm inside a container, interactive. See here. Who are you? Tell me. Who are you?
Bash.
Yes, PID1. You are a PID1 right now. So you know exit command will do what? Exit command will do what? See guys, exit command is understood by bin bash. So here if I type exit, this bin bash will get exit, this bin bash will get exit, PID1 will get exit, PID1 will get exit, container will get exit. Done. You see that? See here, container got exit. But this time I will do that little bit different. Let me create a new container. I am inside a container. Now, without exiting the command, how can I come out of the container safely? Control P Q. Again I am saying Control P Q. I am typing it together. Right now you see container did not get exit. See here. Ubuntu is running. Why container did not get exit? Because PID is running. Keep on running. But I cleverly use some shortcut to come out of it. Control P Q to control, to come out of the control. So guys, now we learn one additional thing. How to, if you are interactive with bash, you can use this command will only work with the control PQ with the bash only. Okay, so you can use control P plus Q to come out of the container. That is the statement. That is the statement. Okay, so see here, container is running. So guys, what I am trying to teach you here is, you have exec, you can execute in a container, attach, it gets attached to the PID, use control PQ to come out of the container if you have exec. So this is the stuff which we should write down. Now the next question was, how can I access from outside using port? Guys, think logically first. Let's understand. Think. Simple way I am explaining to you, okay? This is your phone. This is your router. This is the internet. Coming to the router. Through the router, all the laptop is getting internet and mobile phone also. So guys, I am in the second home. Okay, I am using the same internet. I do have a router. I am having laptop too. We both having different home. So tell me guys, can I connect from here to here? Tell me, is it possible? No. No. Why no? The same network, no? Same internet provider.
You have to get the static IP address and then actually.
So guys, yes, you can connect from here to here, but what you need to do, you need to have a one static IP address at the router level. You only answer this question. I am not saying. You only taught me. So here you need to have a static IP address. So what I should do, I cannot go here to there directly, but I can go to here to this IP address. Now, when I reach here, I will get rerouted, route table. Then you need the RT, route table. If you have worked with AWS, VPC and all, you know that. So from here, I will reach out to here, and from here, routing will be done. This is possible, right, guys? Correct, no? Right? Yeah. So now let's understand how container works. This is your node, okay? VM or node, whatever it is. And now here you have one IP address, node IP address. Okay? And here there is one component which is called Docker bridge. Okay, Docker bridge. I'm not confusing you with the Docker bridge too much. I will explain you later. But this is a bridge. You can say bridge. Now, what is a bridge? I will talk about a little later. And this is the H0. What is happening? H0. Okay. Now, what is happening? The container which is running inside the VM, actually, that will get releasing the IP address to this. So can I connect from here to here? Yes. Here to here? Yes. But can I connect from outside? No. Why? Same concept. So what we can do is, I can connect to the IP address of the node. Now, from the node, proxy should be redirected to Docker 0. Okay. And then you can connect to this. At certain port, this. So here, let's say, think about it. Each container is running on 80 port. Okay, this container internally. Okay, understand this. Internal port, okay. And now, I will have to remember this IP address and suppose if I use 81, so it will come here at this IP address 81 and it will redirect to 80 internally, different IP address. Different each container get IP address 80. Now 81 I have used it. Can I use it 81 one more time at the host machine? Can I use? No. Why? Because only one network namespace is there. So I have to make it 82. So if I try 82 this time, it will redirect to this one. So this internal IP address will remain same, but this external will be changed. So guys, this is one of the way. In fact, AWS uses the same technology. That's the reason they give you private IP and public IP address. Private IP address internal, public IP address external. Okay. So many technologies working the same way actually. So how can I access from outside? So guys, I have container. Look at my screen page. Here, Docker is. I have a this Yankee. If I go to IP address, Docker, inspect, okay, and then grep IP address, and here the IP address is this one, and can I access locally? Ping, see I'm setting, pingable, see it's pinging, but can I access from outside? No. Can I access this Jenkins server internally for HTTP 8080, okay? See, login page. Can I access the same Jenkins server from outside of the node? No. Why? The reason you know that. I cannot access that. So I can access IP address. Understand that? Of the node, but I cannot access the container. So what we need to do, Docker So simply what you have to do, you have to create a proxy. So docker run -t -d detach mode -p. I don't want to become a so -p external node IP address, container IP address. Remember here, run always create a new container. So this is a node IP address, container which is you are running with this, and then Jenkins. And you see that. Can I run this command? Look at my screen, please. See here. Look at its table. See, this is the two container. 1, 2. See here. This is running on 8080. This 2 is running on 8080. But port forwarding is happening from the anywhere to 8080 port on this host. Here is not happening. So which command is making this port forwarding happen? I can see, we call it port export, port forward, port proxy, whatever you want to call it. Everyone nowadays is using this technology only. So can I access this container now? Let's use the IP address. What was the IP address? I think where I kept here it is. And this is a static IP address of the node. See here, Jenkins. This is my first container. Do you want to get one more container? Create it with expose again one more time. See what has happened? Guys, what has happened? Guys, what has happened?
The port is already allocated.
Which one, internal or external?
External.
External. You got it. So I have to change this to 1. And this is the 1. Second container of Jenkins. Yes, that's true. Load balancer will not work in this scenario, but still you can access it. How to make this load balancer working, I'll teach you in this Kubernetes. Still you can access. So guys, what I'm trying to say here is -p is the option you can try and get this working done. Okay, so yes, you can expose and close it. So guys, this is the command I tried. So let's do a little bit of recap before complicating so many things at a time. What I said, first I proven what is container. So here, these are the commands I run in order to trace it. Do not run any command blindly. Okay, have some logic in your mind, something you should pop it up in your mind, then run. Then rules, please remember this. Then run behavior, run with -d behavior. How can I go and stack the container with exec command, attach command, control PQ. How can I access from outside, -p option. So guys, did you understand the behavior of containers? Everyone?
If you liked our Docker session so far, please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.